So the forces in figure 1, as shown, act on an object with a mass of 1.5 kilograms. And so we have force here of 5 newtons. Not necessary, but cool to point out. And what we know is that we're looking for acceleration in the x direction. So we're really only looking here and here. When I see mass in a force diagram, the first thing I'm throwing on the board is my fat force equals mass times acceleration equation, which thus can be rearranged to acceleration is equal to F net over the mass. Now to find our F net in the x direction, like I said, we're only looking at these. So that would be 4 in the negative direction plus 2 in the positive direction, which will yield 2 in the negative direction newtons. So now we have our F net, which is -2 newtons over our mass, which is stated here, which is 1.5 kilograms. And that will yield, once again, 1.33 repeating meters per second squared in the negative x direction. And that will be your answer for right there. So now we'll begin with the second part of our question. To find our acceleration in the y direction, we are going to be looking at the y components of our chart. These two oppose each other in the y direction, so we're looking at this, and looking at this. You'll notice that they are the same. This is a positive 3 newtons, positive y direction. This is a negative 3 newtons in the negative y direction. So F net is going to be equal to that -3 plus that +3. That's not +3. Which, of course, if you've taken a basic math class, you'll know will equal 0. So if we bring that F net into that equation here, acceleration in the y is going to be equal to 0 over our mass, which is still 1.5, thus 0 meters per second squared is our acceleration in the y direction.